Hello, everyone. Welcome to Better Engineering's first webinar. It is called Quick Bites, and it is on our massive machines. We're going to start with introductions. My name is Cami Jones, and I'll be your host today. I've been at Better Engineering for about 3 years now, and I've been loving every second of it. All right, Ryan, you want to start?
Chris, my name is Ryan Hiss. I'm the Vice President of Sales and Marketing for Better Engineering. I've been with the company for about 9 years, and over the course of that 9 years, I've sold many massive machines. And I think one of the coolest part about selling this type of equipment is the parts that actually go into the system. So these massive machines will clean things like rocket engines and missile silos and massive diesel engines. So once these things actually get installed, to see these parts come in and out of the system, it's pretty mind-blowing.
Michael?
Yeah, my name is Michael Jones. I'm a mechanical project engineer here at Better Engineering. I've been here for about 2 years. I'm a certified SolidWorks expert, and I enjoy using that skill set as well as my abilities in project management to help our customers tackle their most difficult design challenges. Thank you for including me in this panel today.
Carl?
Good afternoon. My name's Carl Martin. I work in the sales department. I've been with Better Engineering for over 30 years. I am currently semi-retired, working about 3 days a week. I started out in the electrical department. My background prior to Better Engineering is motor control. Started building electrical control boxes. From there, I went into customer service, did troubleshooting, parts ordering, visiting customers to help them with their machines. Then I got into sales. Probably been in sales about 20 years. During them 20 years, I have seen many major manufacturers such as the automotive, big automotive, the big aerospace people, down to little companies like transmission shops. I would say the highlight of my career was going out to see Jay Lennon at his garage and putting a machine out there, showing them, the operators, how to use it, and also taking a tour of his garage.
Nice. And if customers would like to see that, we do have a video up on our YouTube. All right, Jeremy.
Hey, everybody. I'm Jeremy Salkin. I'm the Director of Operations here at Better Engineering. And before that, I managed the engineering department. And before that, I was a mechanical project engineer. So I've been here for over 10 years. I've designed lots of really large machines and seen lots of them come together. So I'm really excited to talk about them today.
Nice to hear. All right, we're going to get started with this webinar by discussing just our machines and just the vastness of them. Ryan, can you speak to our massive machines?
Yeah, so as I mentioned, I've sold a lot of these massive machines over the course of my 9-year career with Better Engineering. And they can, if you look at batch washers or turntable washers, the turntable diameter can get as large as 200 inches in diameter. The height can be 200 inches high. Our conveyor washers can be about 16 feet wide. And they can clean a whole array of parts, right? So some of our big systems are actually designed to clean rocket engines. So, parts going into space, in particular rocket nozzles. Also barrel panels for the space industry. That's another common part that will go into these systems. On top of really just massive like diesel engines. You're talking like 20 feet long and 15 feet high. So these massive parts washers are designed to clean a lot of different types of parts.
Nice. Jeremy, you've been with the company for a while. You've been one of the great minds behind many of our bigger machines. Do you have any that you've worked on, any notable ones that you've seen us build?
Yeah, absolutely. One of the ones that I actually designed, I may be a bit biased on that, but it was one of my favorites. That was actually a almost 100-foot long system that required a conveyor and a monorail system built into one really long, continuously run machine. So one side of it handled really big cast metal parts, and the other side of it handled the plastic dunnage that these parts were transported on. So that was a really neat project, just in the scale of it. It was so long, we had to break it into lots of different chunks to ship it and install it. It was a really neat one.
Nice. So is it typical to put these machines or different systems together like this to create something new and really big?
Absolutely. Yeah, we can take design elements from certain machine lines and combine them with design elements from other machine lines to create something totally unique to our end user, but that's rooted in very common designs that we have lots of experience in. So for that example I just mentioned, we took our conveyor line and our monorail line and married them together to give a totally custom system to this client.
And to piggyback on that, a lot of these machines that we're making massive are actually founded in a standard design. So we're taking a turntable washer and just making it the turntable diameter wider or making it taller. The same thing with conveyors. We're just taking a conveyor and making it wider. So a lot of these machines are already founded in a tried and true design.
And in addition to those size changes, the capacity changes are well within our wheelhouse as well. Some of the big turntable units we've built to hold 40,000 pounds. Some of the big conveyor style units we've built to hold thousands of pounds as well, conveying parts through them. So not only can we go bigger, but bigger and more robust as well.
So what are the challenges to building more bigger, more robust machines, Ryan?
Yeah, so the sales process for a machine like this, it can go for as long as, a year and a half to 2 years. So it's a very meticulous process. Typically a machine this big, it's an expensive piece of capital equipment, and you want to make sure that it gets installed without any hiccups and it meets the customer's expectation. And one thing that I want to mention too is, we often sell these big machines to companies like space companies whose product line is ever evolving and they're evolving quickly. So you want to make sure the customer has the foresight to buy a machine that will be large enough to accommodate their parts, 3 and 5 years down the road.
So would you say that's one of the more important things when designing larger machines, or are there other important aspects that go into this?
So like purchasing any machine from us, I think one of the really important aspects will be testing. We have a test department that anybody can send parts into for free with all of our standard equipment. And we'll run tests on that part to make sure that whatever machine we're quoting will meet their expectations should they want to move forward with that system. So, on top of having the foresight to plan for a large enough machine, we also offer testing in which they can send parts in that will test clean at no cost to them to prove that that machine can meet their expectation.
Well, speaking of testing, Carl, what can you tell us about testing?
Well, as Brian said, we do encourage customers to send parts in, allow us to hand touch them, feel them, play with them. We have a complete test lab. We have many different types of machines in there. We have the capability of modifying the machines to fit the needs of the customer that we're getting ready to prepare a quote for. We'll take that part, put it in a machine, run it, get a good understanding of how clean the customer is expecting that parts to be. A lot of our customers in a lot of industries, they have different ways of knowing that. For example, in the automotive industry, they may do grammanometric testing. A lot of companies do dyne testing, water brake, black light testing, or just a simple white glove test. But we want to make sure whatever machine we're quoting is going to meet them qualifications. Upon completing that test, there is a very detailed report with photographs and a lot of information. And that information is for the customer's use, but also for our engineering use when they get ready to design that machine. For example, during that testing, we ask the customer how many parts they need per hour, and we work out a cycle time. That way, when it gets to engineering, they know exactly what they're dealing with. We do encourage customers to come in for that testing. They turn around, they come in, we'll pick them up at the airport, bring them to the factory. They can watch the test, they can play with the machine, get a good understanding how it's going to work, meet the people, the engineering project manager, the company's president, vice president, et cetera, meet everybody here and get a good feeling for what better engineering is really about.
And for testing as well, we're not just testing to prove out a specific machine, we're also testing to prove out a specific chemistry. So we're actually offering, a soup to nuts solution to define the full process, not just the machine, but the chemistry going into that machine, which actually can make a significant difference as it pertains to cleanliness results.
Okay. Do you have anything else that we feel customers should know about testing and our testing process? Jeremy?
So for some clients in the more sanitary industries, food, pharma, that sort of stuff, we do also have capabilities to run EB tests and ATP tests for looking for bacteria and those sorts of things to prove out that we can truly sanitize a component as well.
And I think it is important to note that we do have free parts testing as well for our customers. Carl, do you have anything to add to that, or just want customers to know about our free parts testing?
Well, yes, it's one advantage to come in to see the testing because Maryland's known for their crab cakes. We do supply lunch during that. So if you like crab cakes, you're thinking of a machine, you have parts you want to test, come to Better Engineering, we'll take care of you.
And I will say crab cakes are the best here. So up next is our engineering and design process. Michael, what can you tell us about that?
Yeah, so once the testing's done and once you've placed your order, every single one of our custom machines has a project engineer, such as myself, assigned to it. We begin by getting all of the stakeholders in the project in a room, from sales, engineering, and fabrication, to review the order in detail. We look at that test report that Carl was talking about. We see what specifications have been laid out to us by our very detailed sales process. And we identify risks and challenges and create a plan to mitigate those down the line. Large machines, like we're talking about today, have a lot of challenges. And it's really critical to identify those at the beginning to ensure that the project is a success long term. Once that meeting is done, we start creating a fleshed out 3D model of the machine, and hold multiple reviews, both internally and externally, to dig into the details of the machine. We really take our time to dig into the fine details of the design during this time, because as these machines get bigger and more complex, and even on our smaller machines, we don't want to encounter these issues down the line. It saves us time, gives the customer their machine on time if we get that done at the beginning. As the design is completed, we send out an approval drawing to the customer, and the customer can review that. And we really, the key point of our design process is the collaboration and communication between Better Engineering and the customer. We need to make sure that the machine is going to meet their needs. So this approval drawing is kind of the final step of that collaboration during the design process. Once that has been signed and approved, we move on to our fabrication process.
Well, speaking of our fabrication process, Jeremy, what can you tell us about fabrication, shipping, and support after and during the process of ordering one of our bigger systems?
Sure. So building these really, really big systems requires a really big facility. So our facility is very, very large. When we built this facility out, we made sure we had very large build cells to be able to build very long machines and the ceiling height to be able to build very, very tall machines. So we've built 100-foot long machines in here. We've built 30-foot plus tall machines in here. We also made sure that we built in a very big bay door So anything that can be shipped down the road can be fit through our bay door. While we're building these machines, our build teams are very expert in handling large pieces of equipment. They're great at rigging safely and unrigging when we're done with a machine. Before we finish a machine and break it apart, we'll do really rigorous testing. These really large machines can sometimes have lots and lots of components on them, which we'll test as rigorously or more than some of our more medium-sized machines. So we have an ISO 9001 certification, and that requires us to go through a very strict set of testing protocols to ensure that we have the top quality product and processes. When we do ship these machines out our door, they are fully tested, fully signed off internally and externally by our clients. And going out the door, we have a variety of shipping techniques that we are proficient at. So we make a lot of large wooden crates. We also do shrink wrapping techniques. So depending on the needs of the machine and the location of the client, we'll use a combination of different techniques to make sure that we have a really good, safe shipping process. And we've shipped huge machines all the way across the country. So one of the ones that Ryan alluded to earlier was actually built with the bottom half of the cabinet separate from the top half, which is separate from a huge roll-in door. And those three pieces were crated in an appropriate method for each of them and put on three separate full-size flatbed trucks and trucked all the way across the country without a scratch on them. So we're able to break machines apart and ship them like that. But when the machine gets to the client's facility, we do all that stuff in reverse, where we'll reassemble the machine. Our techs will be there to help along the way and do a lot of this reassembly work. And then once it's reassembled, we will rerun the machine, retest it, make sure that everything is running just right, and train the client to have ownership over that machine. So that's going to be everything from the machine operator to the maintenance tech that's going to be making sure that that machine continues to run smoothly.
So would you say that the systems are pretty easy to use? How long does it take typically to train someone to run these completely and totally without any help?
Training the operator is an extremely easy process. We have large full color touch screens on all of these machines. So it's no more difficult than pushing the button on your smartphone. So it's very intuitive for a lot of people to be able to run the machine very easily. It's slightly harder to do the setup on the machine. So to go in there and set the time that you want your heaters to come on or your oil skimmer to come on, that sort of stuff, or set up recipes. So that's where our technicians will be able to come in and help somebody understand how those processes work. Even that is only a 30-minute task or so to understand how to set those things up. So it's not terribly difficult either. Training the maintenance technicians, our install techs are the ones that have been out there in the field running these machines at client facilities for decades, going and installing these machines. So they're absolutely expert in training maintenance techs to keep up with the machine, to keep it running nicely, to know exactly what to do on a daily, weekly, monthly, yearly basis. And we'll provide written documentation as well for maintenance requirements on all of these machines.
And Jeremy mentioned processes. We're an ISO 9001 company, so we've got really strict processes and procedures that we're constantly iterating, to seek continuous improvement. And because we are ISO 9001 certified, and because we have these really strict processes and procedures, we can guarantee that we deliver a quality product to our customers.
That's a great point, Ryan. One of the things that came out of the ISO 9001 process in the past with relation to installing machines like this was that we thought it would be wonderful for clients to have really, really quick support. So they've always got Michael on the other end of the phone, a phone call away to help them through what they need as they're starting up the new machine. And in addition to that, If they need actual program changes done to the machine, we now have rapid support capabilities. So we can put in a certain module into the electrical enclosure that allows us to link into a machine and see what's going on with a machine and even change the program remotely if a client calls in and has a question or wants to see a change. So something that used to require putting somebody on a plane and flying them across the country to make some changes or to troubleshoot something now can be done in a matter of minutes. So that's a really important capability that's come out of that continuous improvement process.
Yeah, and you mentioned our technicians. We've got, and if we have to send somebody on a plane, we have a phenomenal group of technicians that fly all over the world to keep our machines online, because a lot of our customers now, they're running lights out, right? They're running 24/7. If that machine goes down, that would be a major, a significant expense for our customers. So we do everything we can to make sure that these machines are online 24/7, and that includes sending, a group of technicians out if they have to fix a machine.
And to speak a little bit more to what Jeremy said about our record support, if you guys do want to find out more about record support, please don't hesitate to look us up online. We do have both a blog as well as a dedicated page to the system and to teach customers about what it is and how it works. Michael, so you have worked on a really, really, really big machine recently. What can you tell us about that?
Yeah, so this machine was designed for a system that will hopefully revolutionize the aluminum canning industry. This machine is designed to wash large spools of thin aluminum sheet that's conveyed through our washer over rollers at roughly 200 feet per minute. This machine incorporated a few of our standard machine styles. So, like Jeremy and Ryan and Carl have been talking about, we do combine machine styles. So, this had a spray cabinet and an immersion cabinet, and it also had a dry cabinet, and it had a total of 6 modules in one machine. Um, this these are our standard concepts, but this is larger and a different combination than we have ever attempted before. Um, all in all, this machine was roughly 40 feet long, 10 feet tall, and about 10 feet wide. Um, all of the spray modules and the immersion modules totaled to hold about 7,000 gallons of water when completely filled. And all of that's very impressive, and the size of it's impressive. But the big win for me and the win for us, I think, was the fact that we had to implement this and integrate it with their system that was currently in their facility already. Um, that was where collaboration was king. I talked about collaboration earlier, and how it's key to our design process. That collaboration never stopped on this project. I had to work closely with the customer to fully understand all of their needs, what their facility requirements were, how it needed to interact with other equipment near it, and how it had to fit in a very tight window. So it took a lot of work to just come up with a solid machine that would meet all of these needs. Um, this collaboration involved weekly meetings, and I even went out and visited them to see their facility and meet them in face to face to develop that um, personal relationship to get a really good base for communication. And like Jeremy alluded to, that collaboration doesn't stop necessarily when we ship the machine. I'm available, um, and our customer service team is available well after the machine's been shipped, to solve any lingering issues or questions that the customer might have. Um, while this project was full of challenges, like I described, it was really, really rewarding for me as an engineer, um, because we gave the customer a successful machine. Um, Regardless of complexity or customization, that is our goal with every single project that we put through the doors of this building.
Carl, you were the sales lead for this particular machine, yeah? So what can you tell us about it from the sales perspective?
Well, this particular machine started about 2 years prior to shipping. It went through a lot of design revs. The machine actually started as a different style and ended up being the unit it is today. Thanks to Michael and the sales team and everybody at Better Engineering testing, we were able to send a good qualified machine to this customer.
And some of the qualification of these machines happens all the way along the way. So, you know, Ryan and Carl spoke about everything that happens pre-sale, and Michael spoke about a lot of the stuff that happens in engineering. And I spoke a little bit about the testing process, but part of the testing process is holding a factory acceptance test, or FAT, or sometimes called runoff, where a client actually comes into our facility to run a machine to make sure that it's going to meet all of their needs before it ever goes out our door and gets installed in the field. So we try to run a machine here in as a most realistic a manner as we can. We have a huge electrical system feeding our building and gas heat, and we'll put through lots of endurance paces on every machine in as real a condition as possible with the client here to make sure that when it goes into the field, everything runs really smoothly.
Brian, do you have anything to add about this machine?
Unfortunately, I didn't have too much experience with the machine, but what I do know is this, and that's the customer is extremely happy with this system. And so hat off to Michael for designing such an incredible system. And, you know, we've got an extremely happy customer, which is what we all want.
That's so very true.
Yep.
Well, thank you all for being so informative. Everything was super insightful. I've learned a lot. I'm sure our customers have learned a lot. And if customers have any questions or comments, please don't hesitate to reach out to us. You can reach us at Better Engineering Marketing at betterengineering.com. Let us know if you have any questions. We'll be more than happy to answer your questions as well. Thank you all for tuning in today. We've had a great time with you. Thank you so much.
Thank you.
Thank you.
Thank you.
Thank you.
Take care.